Warahmatullahi wabarakatuh. Today we'll be talking about the chapter called Logic in our KNX Advanced course. Okay, this chapter will have two questions in the theory exam, and in our question bank we'll have 19 questions. Okay, so what is logic and why do I need logic? Okay, logic is I need logic when I need to put two conditions or more together. So I need to make an action based on two conditions. So it's not a simple pressing a button then I have lights on. No, but I need to put more logic, like pressing a button and time is this time, or pressing a button and door is open, then lights will be on. If not, then lights will be off. Okay, so it's more of an if condition. Okay, based on other parameters. Okay, how can I implement logic in our KNX systems? We have three ways to implement logic in our KNX systems. Some of the actuators come with logic operation built on them, and I can activate them using ETS. Okay, this is a little bit confusing and depending on the manufacturer, so you need to read the manufacturer manual to find out how to use the logic operation in the actuator. Okay, the other way is using a logic module. This is a module dedicated for logic operations. Okay, and it will have more functions about logic, and we'll talk about it in few minutes. Or, which is we normally use, is the server operation. So in, let's say, 99% of our projects are using server operation, and this is what we are going to do in the practical part. We'll do a scenario or a condition, a logic condition based on server operation. The first two parts, like with the normal actuator or using the logic module, actually is not being used anymore in our modern KNX installation. We used to do this in the old days, but currently we don't do that, because normally I have to nest a lot of group addresses together, and nobody is doing this anymore. Okay, anyway, we'll talk about them in a theory way, just for our knowledge, for our reference, because maybe also we need them in the exam. But in the real life, our operation will be using the server operation, and this will be covered in the visualization part, visualization chapter, and also covered in our practical sessions, inshallah. Okay, so he talking now about logic connection using a normal switch actuator. As we said, a normal switch actuator, some of them come with logic operation built on in the switch, basic ones, depending on the manufacturer. So normally I can get a NOR operation with delay and the function and some extended logic. Okay, so where can I activate that? In the ATS, normally you find some parameter talking about logic. Once you activate it, you can get a lot of logic functions that you can use as well. Some of them also have an extended logic function, which can also be used. Okay, group objects about logic. So what kind of objects I got when I activate logic? Normally you get a group object called logic, maybe logic 1, logic 2, depending on the actuator you have. Then you can link them together using a gate or using a logic function like AND or OR, and then you take the output, and the output you do something with it. You do actions with this output. Okay, so an OR function with off delay, you can activate it from here. So you activated the OR function, okay, from here, and then you can put also some kind of delay if you need. So it's all from the parameters. Here trying to explain what is an OR function, and as you can see, an OR function is very simple. If there is 1 or true in the condition, then the function will be true, or 1. So 1 and 1, or 1 and 0, all will be true. The only way that I got a false or a 0 at the end, that I have 0 or 0. Okay, so you can see it here. So when I have 1, even with 0, I got 1. If I have 1, even with 0, I got 1. Okay, if I have 1 with 1, I got 1. Okay, this is the OR function. Okay, which is very simple. Here the same OR function, but depending on the manufacturer, I can put additional time delay. So I can delay the switching activation. Okay, like here. So I have a T1 or a TE time delay activation. Okay, so that switching object will not come here, but will come here. So the AND operation or the OR operation in our case will start from here. So from here I got the output, not from the beginning, because I have a function. Also here the 0, that the diagram should finish here, but with the time delay it will finish here. So this is why my output will finish here. Okay, same thing with the AND function. The AND function will mostly have AND or true or 1 only if both are true. But if I have a 0 in the equation or a false, then function will always be false. Okay, and this is the explanation. Okay, so whenever I have 1 and 1, I get a 1. If I have zeros coming with zeros, then it's zeros. Okay, I can do the same with a time delay, same function. So the one will start here, not here. This is why I'm starting my output from here. Okay, same function like what we have in the OR with delay. Okay, this is where I can have extended logic. I can activate from here and from here. Here is the group address. You found more details in the PDF, and as I told you, you will not need this in your practical life most of the time, unless you are supporting a very old project or something like that without a server. Okay. Okay, here is how to link the group address together. Okay, to make sure that sometimes you cannot put two group addresses. You cannot put a lot of group objects in one group address, so you need to put group addresses and link them together. Okay. Now we're talking about the other way to control, which is the logic module. With the logic module, you have more functions because logic module can have transfer times. Okay, so they can delete the telegram in total. They can have cyclical sending, so they will be sending the telegram more and more based on specific time frame. Okay, so these are a lot of functions, as you can see here, with the logic module. Okay, let's go through them in a simple way. So one of them is format converter. Let's say I have a 1 byte group object, and I need to take part of it, like the second bit as an example, and put the value of the second bit in a group address with another group object which is 1 bit. Okay, I can use this using format converter. So I take my input as the 1 byte, okay, and then I specify here that the format converter will depend on the second bit. So the logic gate will take the 1 byte, strip it all, only keep the value of the second bit, is it 1 or 0, takes this value in another group object for me, and then this one I will use in the group address with the other 1 bit, because as you recall, in the group address you cannot put different sizes together, so it will be the same size. Okay, this is a way that you can link group objects together in a group address, even though the group object is not in the same size, but you are taking part of it which is the same size that you need to link. Okay, we have also logic gates with extended now here, so you have AND, NOR, XOR. Okay, so you have some extended here. You can even invert the output. Okay, you can have minimum and maximum value indication. Okay, so you can have the largest value is determined from to send the telegrams. So if it's sending let's say 20 and 26, then you can determine which one you want to take. So you can say that if I have those values coming, take the higher or take the lower one. Okay, you can also have a threshold value detection. Okay, detecting specific value. So if the value exceeded something, then you can have a true or false. Okay, temperature comparator, when you have two values of temperature compared together, and then you can get telegram based on the comparison of the two temperature coming to you. Okay, gate or filter, this is when the condition is active, then a telegram can go. If the condition is not met, then the telegram itself can be blocked. So you send the telegram to the gate or to the logic gate, to the logic module, but it's not going because a specific function is not met. Okay, staircase light, when you put some time delay on the switching itself, so it's emulating that you are going to on a stair. So one step is going, then you are going one step up, then another step is going, something like that. Okay, multiplier, when you take it and multiply it by something. Okay, counter, where you can count the telegrams coming, and then you end up with a group object or the value based on the telegrams you counted. Okay, all of this you can use. Normally you don't use in the practical life, but at least you know the definition of each one. Okay, time delay here, when I have the telegram is being delayed based on another telegram. So when the other telegram is coming, then I can send my original telegram. Okay, then some softwares come with some logic gates or logic modules. With the software, I can make my logic interpretation using a software, something like that. Okay, which is much better, because with this one you'll be able to do some kind of graphical interface, making your group addresses a lot easier. Okay. Normally, as I told you, don't be intimidated by how complicated it looks, because normally you don't use this kind of logic gate anymore. You use it via the visualization software or via server, which we will do in our practical, inshallah. Okay. If you have any question, let us know. See you inshallah in the practical part of the next session. Assalamu alaikum.